Hello everyone, welcome to lecture 4 of my 16 to 18 mathematics series. Lecture 3, the previous one, we looked at the quadratic function, which is a graph of ax squared plus bx plus c, and the highest power of x is 2. And we just did a few sketches of that, and we talked briefly at the end about the roots of the equation, which is the roots is where the graph crosses the x-axis, the point where y is equal to 0. What we're going to look at today is something called the discriminant, and it's tied very closely to the roots of the equation. So here's the form of the equation: y equals, missed that bit out, but something like y equals, or f of x equals, or whatever, ax squared plus bx plus c, where a, b and c are all real and a is not 0. The discriminant, which we give this triangle symbol to, is a number calculated from a real number, b squared minus 4 times a times c. That's all it is. It's these coefficients, b squared, a, c, and 4. Okay. The thing you have to watch out for is the signs. Yep. So, for example, if we had minus x squared, then a would be minus 1. Yep. If c was minus 3, then obviously c is minus 3 here. Yep. So just pay attention to the sign in front of the term. That's the only thing you have to be a little bit careful about. So we've calculated this discriminant here, but we really, why do we do this? Well, like we said, it's tied very closely into the roots of the equation. If we work out the discriminant, and it turns out the value is positive or greater than 0, we have a curve with two real and distinct roots. And it will look something like this. Yep. Here's our two real and distinct roots. Yep. And this is the case where the discriminant is greater than 0. If we have the discriminant equal to 0, we have one root. One real repeated root here. Okay. This is the case when the discriminant is equal to 0. And when the discriminant is less than 0, or a negative number, we get the case where, it's a very thick line, but we get the case where there's no real roots. You see this curve does not cross the x-axis. It has no real roots. And what this does then, it helps us gives us the nature of what kind of roots we have, and it helps us in our sketching. So let's do an example then. Here we have a function, y equals x squared plus 3x plus 5. We want to find the nature of the roots of the equation and sketch the curve. Whenever you see something like find the nature of the roots, it's want you to say how many roots there are and whether or not they're distinct roots. So distinct means separate. Yeah. So if we go back here, these are two distinct roots. Yeah. Here, this root is not distinct, it's repeated. Yep, we have one repeated root. And basically that wants you to find the discriminant. And then we want to sketch the curve. So let's go about this then. If we have the function ax squared plus bx plus c, here we say that a equals 1, isn't it? The coefficient of this x squared is 1. B equals 3. And c equals 5. Be careful with the signs again. If this was minus here, then c would be equal to minus 5. If this was minus, b would be minus 3. Then we work out the discriminant. It's b squared minus 4 a c. B squared is 9. 3 times 3 is 9. Minus 4 times 1 times 5. So you evaluate 4ac on its own. Yeah. The way to go through this is you do b squared, then do 4ac. Yep. So don't try and do b squared minus 4 and then times by ac. Yep. Follow your rules of BIDMAS. You do b squared, then you do 4 times a times c, and you take this bit away from this bit. Okay. 4 times 5 is 20. 20 times 1 is 1. 9 minus 20 is minus 11. So, we then say the discriminant is less than 0. Minus 11 is obviously less than 0. We go back. If our discriminant is less than 0, we have no roots. no real roots. Talk about that in a lecture a long way down the road about imaginary numbers, but no real roots. Look at that, I can do joint writing on a whiteboard. So we now need to sketch it. We have no real roots. Okay, we intercept, our C value is 5, and this is the intercept, so we intercept at 5, and we have a positive value of A is 1 here, so we have a U-shaped parabola, no real roots, intercepts at 5. We could sketch it. It's going to be like this. Okay, something like that. Yep. And that's all that question involves. So you can see the discriminant is very helpful when it comes to sketching. It's a quick way of letting us know how many roots we have and the nature of those roots. So let's look at a few specific cases. These are, you don't really need to know this, but they're just quite interesting. What happens when C is equal to 0? Well, when C equals 0, our discriminant becomes, this whole term for a C becomes 0, doesn't it? Because any number times 0 is equal to 0. So our discriminant just equals b squared. Now, any number squared is a positive number, isn't it? Yeah. And this is 0, obviously. But if b is non-zero, then b squared is always going to be positive. And what that means is our discriminant is always going to be positive. Which, if we double check, a positive discriminant, 2 real distinct roots. So, if C is ever equal to 0 and B is non-zero, your graph will always look like this. Sorry, not like that. Your graph will always have 2 real roots. Now, the other thing is if C is 0, your y-intercept is also equal to 0. Okay? So what that means is that one of my roots is here, the point 0, 0. Yeah, here's your other root. We don't know what this is necessarily. We can work it out, but we'll do that next time. Here is the point 0, 0. Okay, 2 real distinct roots in a point 0, 0. Obviously, if A is negative, then it will look like that. But that's just a special case. What about the case when B equals 0? Well, when b equals 0, my discriminant is equal to minus 4ac. Okay. So what this means then with our discriminant is that, let's just say a is positive, yeah, then the value of our discriminant depends completely on c. Okay? Let's just say a is positive. If a is positive and c is positive, then our discriminant is negative. So what that means then, if when b is 0 and c is positive, we get a graph that looks like this, don't we? Okay? If a is positive and c is negative, we get a graph that looks like this. Okay, let me just label these up. This is a greater than 0, c less than 0. This one is a greater than 0, c greater than 0. And we can predict what happens if it's the other way around. If a is negative and c is positive, we get something that looks like this. And if a is positive and c is positive, and c is negative, so a is negative, c is negative, we get something like that. Yeah. So this is a less than 0, c greater than 0, a negative, c negative. Okay, so there's just a couple of special cases that are quite interesting to look at. Okay, so in conclusion then, we know that we have an equation of the form ax squared plus bx plus c. The discriminant is given by b squared minus 4ac, and the discriminant will give us the nature of the roots of the equation, or where it crosses the x-axis. Yeah, there'll either be 2 real and distinct roots, 1 repeated root, or no real roots. Okay, thanks for watching, guys. Next time we'll be looking at how to solve some of these quadratic equations by using